In this experiment, we'll pull a trolley with a steady force and measure its acceleration using a motion sensor. We'll also investigate the effect of increasing the force. Set up the motion sensor at one end of the trolley. Raise this end until the trolley, when given a push, moves down the runway at a constant speed. The runway is then said to be friction compensated. Run the data logging program on the computer and, from the VT graph plotted, check if the runway is friction compensated. Rescale to enlarge the graph. The graph shows that the trolley slows down. The runway is not friction compensated. The trolley runs faster and faster. The runway is not friction compensated. The trolley moves at a constant speed. The runway is now friction compensated. To find out how force affects motion, we use an elastic thread stretched so that its length is equal to that of the trolley as 1 unit of force, 2 elastic threads stretched by the same amount as 2 units of force, etc. Place the trolley at the top of the friction compensated runway. Attach the end of 4 elastic threads to the back of the trolley. Stretch 1 elastic thread until it is in line with the front of the trolley. Pull the trolley down the runway, keeping the thread stretched by the same length all the way. This is not easy to do. We'll practice several dry runs before recording the data. Now do a real run. Start recording data and pull the trolley down the runway. Note the ST and VT graphs obtained. Change the scale to enlarge the graphs. What do the graphs tell us about the motion of the trolley when pulled by a steady force? The VT graph is a straight line. This shows that the trolley moves with uniform acceleration when pulled by a steady force. Measure the acceleration from the slope of the VT graph. The data logging program can do this readily. Repeat the experiment by pulling the trolley with 2 elastic threads. Measure the acceleration of the trolley from the slope of the VT graph. Repeat the experiment with 3 elastic threads. Repeat the experiment again with 4 elastic threads. Put the results of acceleration and force in a table. Use the data logging program to plot a best fitted graph of acceleration against force. Draw a conclusion from the acceleration force graph. For a constant mass of the trolley, how is the acceleration related to the force applied?